Welcome to clickmyproject.com. Let me discuss the project about content-based microscopic image retrieval system for multi-image queries. In this paper, we propose here retrievals using a supervised classifier with constraints on abstracted features. Gray-level co-occurrence matrix algorithm is implemented to extract the texture features from images. The features optimization is done on the extracted features to select best features out of it to train the classifier. The classification is performed on the dataset, and it is datasets are into three categories such as normal, neuroplastimas. The query image is classified by the classifier to a particular class as the relevant images and retrieved from the datasets. It's the block diagram of our project. First we will load the database. Database is to the microscopic images. The next one is pre-processing. Then median filter will be fine for databases. The next one is segmentation. Segmentation is used to the word segmentation is often considered to be the first step in image analysis. The purpose is to subdivide an image into meaningful non-overlapping regions which would be used for further analysis. Find the threshold that minimizes the weighted within class variance. The next one is feature extraction. Texture feature extraction. The gray level co-occurrence matrix contains information about the positions of pixels have similar gray level values. A co-occurrence matrix is a two-dimensional array in which both the row and the columns represent a set of possible image values. The GLECM is divided into the 12 features is cluster size, dissimilarity, energy, entropy, homogeneity, maximum probability, sum of square, autocorrelation, inverse different moment. The next one is features matrix. Features matrix is used to this moment invariance features. Then is say feature extractions, functions of image moments or projections of the image function into polynomial basics. The next one is relevant result. Relevant result is used to the some of the classifications for such to the KNN search. KNN is the K nearest neighbor classifiers. Place items in class to which they are closest. Must determine distance between an item and a class. Sorting the distances of most number of close images within a particular class under the nearest neighbor index are computed. The next one is classified mutual matrix. The next one is n-class SVM classifier. SVM is support vector mission. Support vector mission is the defines a grouping of all the clauses into distance groups of classes. This grouping is then used to train a SVM classifier in the root node of the decision tree, using the samples of the first group as positive examples and the samples of the second group as negative examples. The classes from the first clustering group are being assigned to the first subtree, while the classes of the second clustering group are being assigned to the second subtree. Then next one is query image. Then already applied to the query images. Then pre-processing, median filter will be fine for. Then segment is used to the votes method. Then next feature matrix and feature vectors. Then n-class classifier. It's used to do this process continues recursively until there is only one class per group, which defines a leaf in the decision tree. Now let's see about the execution part. I am having cbr main.yum file. Then select the file, right click, run file, then select query image. Here we have to select the input image for query image 1, then second query image 2 for select. And query image 1, query image 2 is selected. The next with the segmented images by using votes segmentation is often considered to be the first step in image analysis. The purpose is to subdivide an image into meaningful non-overlapping regions which would be used for further analysis. Find the threshold that minimizes the weighted within class variance. This turns out to be the same as maximizing them between class variance. Operates directly on the gray level histograms, so it's fast the histogram is computed. Then next one is feature extraction. It's the first image query on relevant images for used to the texture feature extraction. Gray level co-occurrence matrix contains information about the positions of pixels having similarity gray level values. A co-occurrence matrix is a two-dimensional array B in which both the row and the columns represent a set of possible image values. Then the co-occurrence matrix obtained, we have to extract the 12 features for contrast, correlation, cluster prominence and cluster size, dissimilarity, energy, entropy, homogeneity, maximum probability, sum of square, autocorrelation, inverse different moment. And next one type of features for safe features. Safe features is this is the second query image for relevant images used to the moment invariance functions of image moments. Moments are projections of the image function into a polynomial basis. Invariants are functions defined on the image space such that the dimensionals for different n of the moment invariance. Then different classifications are used to this relevant ID and distance are calculated to use to the classifications for multi-SVM. This defines a grouping of all classes into distinct groups of classes. This grouping is often used to train the SVM classifier in the root node of the decision tree, using the samples of the first group as positive examples and the samples of the second group as negative examples. The classes from the first clustering group are being assigned to the first subtree, while the classes of the second clustering group are being assigned to the second subtree. Then the second query images for relevant ID and distances by using GLCM features and SVM and KNN classifiers. KNN classifiers is the precision and recall analysis. CBR performance is analyzed by computing the values of precision and recall. Precision equal to number of relevant images divided by total number of images retrieved. Recall functions for number of relevant images retrieved by total number of relevant images in the databases. Then we have to present a novel content-based MR images slide retrieval algorithm. We have demonstrated that by using the proposed weighting scheme inspired by IR theory. The slide level retrieval performance of the CVR system is considerably better than a traditional image level retrieval accuracy for all 7 substeps of two changing disease, which have inter and intra-reading semantic variations, intra-slide semantic variances, and inter-subtype visual similarities. Application of the proposed weighting strategy inspired by the IR theory is limited to microscopic images only and can be also useful for any type of micro query search and content-based retrieval systems. Thank you.